All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is significant figures in scientific notation. If you don't have a calculator, you're going to need one. So go ahead and pause the video if you don't have one and get access to one. Let's look at number one. It says state the number of significant figures in each measurement. We have 734 grams. Remember that non-zero digits are always significant, and so we have three significant digits in A. The 7, the 3, and the 0 all mean something. They mean 730 and 4 grams. Let's look at B. We have 82.400 meters. Remember that trailing zeros count, but only if there's a decimal, and there is. So those zeros matter. They count. We mean 82.400. Those zeros are not just holding a place. They actually mean something. So 5 significant digits. C, we've got 92,000 degrees Celsius. There's no decimal at the end, but that means that these last three zeros are not significant. You may ask, well, if they're not significant, why bother writing them? The answer is because 92 degrees, while it's quite warm, is less than the boiling point of water. 92,000 degrees is vastly more hot. And so you have to hold the zeros, have the zeros to hold those places. We've got 92,000 degrees Celsius, only two significant figures. Let's look at D. We've got 0.003 seconds. Remember that leading zeros never count, whether there's a decimal or not, doesn't matter. There's only one significant digit in that number. Let's look at E. We have 607 liters. Trap zeros count. Trap zeros always count, so we've got three significant digits in that number. Let's look at F. We have 1 times 10 to the minus 4th hertz. All right, that's a unit of frequency. So 1 times 10 to the minus 4th hertz. Remember that this is the only one number that matters. There's one significant digit there, so I have a total of only one significant digit in my answer. Let's go on to number 2. Round the number to at the left to the number of significant figures stated in each column. We've got 84.631. The question is, does this one push this 3 up? The answer is no. 5 or bigger is required to push that number up. It's just not big enough. The 1 does not push it up. So it would be 84.63. Let's take a look at the next one. We've got three significant figures here. We're going to look at this number here and ask, does this 3 push this 6 up? It's not big enough. It would have had to have been 5 or larger, so it's 84.6. Let's look at the next one. We've got 84.6. Does this 6 push this 4 up? It does indeed. So we've got 85, two significant figures for that one. 85. And finally, the last one, one significant figure. The 5 is big enough, barely, but big enough to push the 8 over to 9. So we've got 90. Remember not to write a decimal after the 0 because that would render both the 9 and the 0 significant. Well, that's not what we want. Let's look at the next one. We've got 0.94500. We want 4 significant digits. The first one is irrelevant. It's in the front, so leading zeros never count. The question is, does this 0 count? Yes, it does. So we have 0.945, and we'll take one of those zeros. That's our number. Next one, 3 significant digits this time. We just knock off that last 0. 0.945 would be 3 significant figures. Let's look at the next one. Only 2 significant figures. Is this 5 big enough to pull this 4 up? Yes, it is. 5 or bigger. Barely, but it's big enough. So we get 0.95 for 2 significant figures. And this one's a little tricky. The 5 is big enough to push the 9 up, but 9 pushes up to a 1. So that gives us 1 right here. So we have 1 would be one significant figure. Let's look at the 7.95310. We want 4 significant figures. So I'll ask myself, does this 1 kick this 3 up? No, it does not. It's not 5 or bigger, so it's just 7.953. The next one is, does this 3 kick this 5 up? No, it does not. It's not big enough. We just have 7.95, just like that. 7.95. Does the 5 kick the 9 up? Sure does. It kicks it up to a 10. That's going to kick this 7 up to an 8, and we have 8.0 for 2 significant figures. And finally, one significant digit would be 8.0, then 0 knocked off. It would just be 8. The next one, 2,058,268. We want 4 significant digits. Does this 2 kick this 8 up? No, it's not big enough. So we leave it at 2,058,000. Remember to hold the 3 zeros. Hold the places with these 3 zeros. So 2,058,000. If I want only 3 significant digits, I'm going to ask myself, does this 8 kick this 5 up? Yes, it does. That would give us 2,060,000. 2,060,000 for 3 significant figures. And next one would be this one right here. We're going to have 2 significant digits here. Does the 6 kick the 0 up? It's big enough, so it kicks the 0 up. We got 2,100,000, just like that. And then for one significant digit, does a 1 kick this 2 up? No, it does not. We have to hold the places with this triplet of zeros, this triplet of zeros. We have to hold the place, but they are not significant. Let's go on to number 3. Number 3 says perform the following operations, round the answers to the appropriate number of significant figures, and then label. We've got a multiplication problem here, centimeters by centimeters by centimeters. Somebody wants me to find the volume of something. So what I'm going to do is I'm going to multiply these three numbers together. When I do, I get 747.84. That's the number that shows up on my calculator screen. But unfortunately, I can only take the least number of significant digits of each of the three. 8.2 has 2, 6.08 has 3, and 15.0 has 3. I can only have two significant digits. The 7 is big enough to kick up the 4, but I have to have a 0 to hold the place. 750 cubic centimeters for A. Let's look at letter B. We got 34.8 meters divided by 3.048 seconds. This is a velocity. When I do that, I divide 34.8 by 3.048, and I get 11.417. I need only three significant digits, however, because this one has 3. Now, this one has 4, but I can only have the lesser of those 3. So 11.4 meters per second is my answer. Let's take a look at the next one. We've got 24.5 times 23.4 rather, minus 8.4. Remember, the rules for addition and subtraction are a bit different. When we have addition and subtraction, what we're going to do is we're going to look to the last decimal. In this case, 4 and 4, I look to the number after the decimal. If this one takes me to the nearest tenth, this is the nearest tenth, I can only have an answer to the nearest tenth. My actual computer screen shows 15 just like that. But I'm going to write it as 15.0 because I want one number to the right of the decimal. So 15.0 would be my answer. Let's look at D. We've got 65.48 grams, 3.0 grams, 0.082 grams, 0.882 grams, and 26.46 grams. I'm adding this time. But again, the rule is the same. Addition or subtraction, I look to see what's on the right of the decimal. 2 here, 1 here, 3 here, 2 here to the right of the decimal. I can have one number to the right of the decimal. I've got 95.822. The 2 does not kick the 8 up. I've got 95.8 as my answer. Let's look at number 4. Number 4 says convert the following numbers from decimal to scientific notation. The answer must have the same number of significant figures and label as the original number. We've got 150 million kilometers. It's the average distance from the Earth to the Sun. If I start here on the end and I work my way back, 1, 2, 3, 4, 5, 6, 7, 8. I moved 8 places to the left. So I'm going to write 1.5. I can only have one number to the left of the decimal. 1.8 times 10, 1.5 times 10 to the 8th kilometers. And that'll do it for me for A. Okay? Remember, there's only two significant digits, so don't add zeros on the end. Let's take a look at B. We've got 0.000198 centimeters is the diameter of a platelet. And so I'm going to start here at the decimal. I'm going to go over 1, 2, 3, 4 places to the right. So this becomes 1.98. I want one number to the left of the decimal, but one number only. And then times 10 to the negative 1, 2, 3, 4. So 1.98 times 10 to the negative 4. Next one, we've got 7,400 grams. There is a decimal after the 7,400. So I'll have to take that into account with significant figures. I'm going to move the decimal place over 1, 2, 3 places to the left. That's 7.400 times 10 to the third for C. The next one, D, we have 6 kilometers per hour. This is a fast walking speed. A lot of people would just leave it like that. I think I'd prefer, though, if it's asking me for scientific notation, to say 6.0 times 10 to the 0. Anything to the 0 power is 1. So that makes it a little bit more scientific notation than just writing 6 kilometers per hour. So that's my answer for D. Let's look at number 5. It says convert the following numbers from scientific notation to decimal notation. This time we're going to go the other way. The diameter of the Earth is 1.3 times 10 to the 4th kilometers. To do this, what I'm going to do is I'm going to start with 1.3 and then move the decimal place over 1, 2, 3, 4 places to the right. I get 13,000 kilometers. That's the diameter of the Earth. So A would be 13,000 kilometers. Let's look at B. We get 3.85 times 10 to the 6th. This is square miles. It's the area of the United States. And so to do this, what I'm going to do is I'm going to start with 3.85. I'm going to put the decimal between the 3 and the 8 and then move over 1, 2, 3, 4, 5, 6. 3.85 times 10 to the 6 square miles would be this right here. 3,850,000 would be that value right there. And finally, letter C. We've got 8.0 times 10 to the negative 3 grams. This is the mass of a small spider. And what I'm going to do is I'm going to start right here with the 8, and I'm going to move the decimal place over 3 places to the left. So 1, 2, 3. That gives me 0.08. Remember, that 0 was significant, so I'll leave the 0 here. My answer will be 0.0080 grams. That's the mass of a small spider, and that will do it for this worksheet. I'll see you in the next one. Bye-bye.